Hi and welcome back to my channel. In this video we will try to do parameter tuning regarding the fitting of support vector machine, and for that we'll be utilizing the same data which we have used in my one of the videos which was based on this support vector machine. And for that we have a same categorical variable and 4 different continuous variables. Since parameter tuning is very important because it actually extracts the top level parameters that control the learning process of an algorithm, and ultimately it has a very good impact on the accuracy, how correctly the different classification problems are solved by a particular algorithm. So we'll be focusing on support vector and we'll be doing the analysis part in this R console utilizing the same data set where we have 3 different categories and 4 different variables, and we'll try to optimize and see what are the best parameters that are very much required for solving the classification problem. For that we'll be using a name or giving a name to this function, say hyper is equal to, this is the default code tune, then followed by this default function SVM, and we will always start with the response variable followed by this shortcut method tilde dot comma, which I have already explained in the previous video on support vector machines. Then data, the name of the data is cost, comma, then we'll be giving some range to these different functions in the form of list. Say for example we will start with epsilon function. For that we'll be giving a sequence for that, and within sequence say for example 0 to 1 with an increment of 0.1. so 0 to 1 is the range, and this range changes at the rate of 0.1. then after that what we will do, we will use another one, that is gamma. This is one of the functions which is required in fitting of these support vector machines, and for gamma we'll be giving a value 2 raised to power, say for example from 1 to 10. then we will click on this enter. Since support vector machines or these are actually very much used for solving the classification problems and sometimes also for regression problems, what it actually does, it actually creates a certain kind of a hyperplane which actually classifies the different categories accurately. So our code is fixed. Now the important thing which is very much required to get the summary, so let's click on this. So we have a summary and we'll find from this the best parameters for this range of epsilon and gamma is epsilon value should be 0 and gamma at a value of 2, and which is clearly visible from this detailed performance result, and it's almost 0.05 with a dispersion of 0.016. okay, the best parameters for this is 0 and 2, that is 0 for epsilon and 2 for gamma. Then let us try to plot this, also plot the code which we have used, plot, and within this bracket hyper. So we have a plot. As you can see, the density of the color defines the lower values of the error, and you can see the lower values of gamma and epsilon are quite good for this parameter tuning. And to get the best model for that, we will write the code here. Hyper is the name of the parameter tuning which we have used, and we will try to extract the best model. Then, because this is very much required for the prediction like we have used in case of previous video, we will use the same to get the predictions, predict, and this within this predict we will use this best code or function followed by the name of the original data set. Then we will do the predictions, and we want to create a certain kind of a matrix which is very much used for seeing or assessing the performance of any classification algorithm. So we'll be trying to create the matrix that is known as confusion matrix or error matrix. For that, since it is in the tabulated form, we will use this table. Then we will give some name prediction is equal to actual predicted values. Then actual will be given name to the original data, that is cost. From that we will extract this study variable and enter. Then c.matrix, and within this best parameters we'll see what is the accuracy of our model. So we have a matrix here, and you can see the values within these diagonals are correct classifications, and above and below are misclassifications. Since the Shuhama, the actual, there is one misclassification which should have been in Shuhama, but it has been incorrectly classified as Vadura, and there has been one misclassification in case of Vadura, where one value should have been in this Vadura category, but it has been incorrectly classified. But almost, if you will see, we have a good value of classification or the representation of class. Only we have two misclassifications. So let us get the accuracy. For that, we'll be using the sum of diagonal elements, sum of diagonals for these C matrix which we have created, divided by the total of this matrix. Since this is a default formula, we're making a function for this. So actually this is diagonal, it's not dia. Okay, accuracy. Then let us run this code. Okay, we have a very good value of accuracy, that is 0.98. 90% is a good value as far as accuracy is concerned. And if we will write this accuracy again to get the error rate or misclassification rate, 1 minus accuracy, that is 0.01, which is quite low. This is all about the hyperparameter tuning, where we can get the top level parameters, and in this case the top level parameters are in terms of this epsilon and gamma is 0 and 2, and the accuracy is 98% with respect to these two parameters. Hope you like this video. Thank you very much, and in next video we'll try to demonstrate the tuning and fitting or the combination of neurons which are used in case of a very important algorithm, that is artificial intelligence based neural network modeling. Thank you very much again.